When we first introduced the product rule and quotient rule, particularly the quotient rule, we had a motivating problem which talked about stress and stress in a tube, depending on the diameter of the tube. What we're going to do in this video is look at that application and use the quotient rule to investigate that particular problem. So to recall the problem, we had that the stress, capital S, on a tube and the outer tube diameter, capital D, are related by this function here, S of D equal to 16 dt over pi d to the 4 minus little d to the 4, where capital T and little d were known and they're essentially constants. So basically all we've got here as variables is capital D and the function value itself, capital S. So S is a function of D. Now you can see we've got D on the top there and also on the bottom, so we've got a quotient of two functions of D, 16 dt and pi times d to the 4 minus little d to the 4. So now that we know about the quotient rule, we can use that to investigate the rate of change of stress, capital S, with respect to that outer tube diameter, capital D. So how S varies with D, in other words. So given that function, what we're going to do is look at what is the instantaneous rate of change of stress with respect to outer diameter using the quotient rule. So the first thing we want to do is actually remember what the quotient rule was. In this case, I'm going to let my function u be the top, as we would. Now remember, it's going to be u of d this time, not x, because d is our independent variable. It's going to be 16 dt, and v, again of d, we pi multiplied by capital D to the 4 minus little d to the 4. We're going to need the derivatives of those, u dashed of d. That means the derivative with respect to d. It's going to be 16 times t. In other words, 16t is a constant multiplied by d, so our derivative is just 16t. As well as that, we're going to have the derivative of v of d, v dashed of d, and that's got a constant multiplier pi, and then the function d to the 4 minus little d to the 4. Little d and big D are not the same thing, so we treat little d like a constant. Differentiates away to 0, and big D to the 4 differentiates to give 4d to the 3. So I might actually write this as 4 pi d to the 3. So we've got those, and then we can say that S dashed of d is going to be v by u dash minus u by v dash all over v squared. Let's jump down on the next slide and plug those in. Okay, so S dashed of d is going to be v times u dash, so that's pi times big D to the 4 minus little d to the 4 multiplied by u dashed, and u dashed was 16t. And then we want minus u, which was 16 dt, multiplied by v dashed, which was 4 pi d cubed. That's all got to be over v squared, so v squared is pi squared and the square of this term, factor there. So it's pi squared d to the 4 minus little d to the 4 all squared. I'm just going to neaten up the top there, maybe pause for a second and try that one out yourself. Okay, so expanding that out, I get 16 pi t d to the 4, take 16 pi t little d to the 4, take 64 pi t d to the 4, and the bottom stays the same. I can do a little bit of grouping up here. The 16 here and the 64 there will give me minus 48 of those. So I've got minus 16 pi t little d to the 4 minus 48 pi t big D to the 4 all divided by pi squared. I can see I can get a little cancelling here. So there's some common factors on the top. Okay, I could extract this pi here and here, factor those out, and they will cancel with one of the pi's on the bottom, and I can factor things out a little bit as well. And we end up with our final result there for the derivative S dashed of d. So this function down the bottom here essentially tells us how S, the rate of change of S with respect to change in capital D. So you could look at how stress changes as the outer diameter of this tube changes by plotting that function. And that's using the quotient rule. So again, there are heaps of other applications and contexts in which we use the quotient rule, and for that matter, the product rule. So if you have a look in some websites or textbooks, whichever one you're particularly comfortable using and which one's been working out for you so far, have a look at some of those and see some other uses of these rules. Make sure you're attempting the exercises in the worksheet to get heaps of practice with them as well.